Hello and welcome to our science channel, where every day is exactly like a cold, refreshing can of science. Speaking of refreshing, today's free merch blowout ABC gum. Reach down into that chair, table, wherever you are, feel around, and find yourself today's free merch. Already been chewed gum, ABC gum. Help yourself. Enjoy that. My gift to you, science students. Let's talk just a tad about measuring things today. You're working on your pre experience work in the measurement unit so we can get ready and do a density lab. So, looking at the slide here, it says that all measurement devices have limitations. You must estimate one digit beyond the known value. So, we're going to do an example here. How long is this ice cream truck? And we've got a ruler set up. So, the beginning is here, and the measurement at the end is there. And we've zoomed in over here. We'll talk about that in a second. Excuse me. So, how long is an ice cream truck? We know for sure We know for sure that this ice cream truck is one. We're reading from left to right here. We know for sure that it's two. We know for sure that it's three. We know for sure that it's four. We know for sure that it's five. We know that it's not quite six. So the first number we're going to write down is five. We know for sure that's five. Then we're going to come over here and look where we've zoomed in. We know for sure that it's 5.1, point 2, point 3, point 4, point 5, point 6, point 7. 5.7. That line right there is our point 7. And we know this one right here is point 0.8. It doesn't quite go to point 0.8. So we know for sure that it's 5.7. So those are our known values. We've got to find our known values and then estimate one digit beyond that. So within this space between 5.7 and 5.8, we imagine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We imagine that there's 10 more little lines in there, and then we kind of estimate where it would fall in that region. To me, this right here looks like it's around zero point 0.5 or zero point 0.6, halfway. We all know half is zero point 0.5, right? So our estimated digit would be like maybe zero point 0.5 or zero point 0.6. So we know for sure it's 5. We know for sure it's zero point 0.7. That's what we've written down so far. And then our estimated digit, let's say, is 6, 5.76. And we know this is a metric ruler, so we're going to put our unit there, centimeters. So that's how we estimate one digit beyond our known value. And we do that with all measurement tools that we'll use in the science lab. Here's a little bit more practice with that. We know for sure this arrow right here, we know for sure it's 2, 2.12345 2.6. And we're going to estimate 1 past that. I think it's closer to 7. So I'm going to say my estimated digit would be 7, again, centimeters. This red arrow right here is for sure 5. 5.1234, 5.4. How far past 4 does it go? If you think it's right on 4, then your estimated digit would be 0. And finally, this third one, 7.123, 7.3, and it's closer to the 3 than the 4, so I'm going to say 7.32. And these are, don't forget your units, centimeters. So that's how we estimate one digit beyond the known value using a ruler. The same thing works for a graduated cylinder, which is what I want to review. You've already watched a video on using liquid displacement, reading graduated cylinders. Just some reminders that you need to be getting at eye level. You really need to squat down. Your measurements will be way off if you don't squat down, have the graduated cylinder or the beaker sitting on a bench so that it's not tipped one way or the other. Get down to eye level. Look for the bottom of the meniscus. Liquids have adhesion and cohesion. They stick to themselves. They're weakly attracted to themselves, and they're weakly attracted to their container. So this part here is where it's sticking to the side of the container. The actual liquid level is down here. So you have to get down to eye level and read at the bottom of the meniscus, and you follow that, estimate one digit beyond the known value rule. I wanted to touch on that liquid displacement technique real quick again. We're going to use this, and this isn't real precise, these cartoon drawings, but we're going to say that we start with 15 milliliters of water in here, and we put this pencil in, and now it goes up to 20 milliliters. What's the volume of our pencil? This is what we're doing here. We're using liquid displacement, some sort of liquid, to determine the volume of an object. And remember that volume is how much space something takes up. So we put the pencil in, and the space that it's taking up inside here, it was 15, now it's 20. So 20 milliliters minus our initial 15 means that that pencil, it takes up 5 milliliters of space. Now, the one of the interesting things about this is milliliters is a measurement of liquid. Liters measure liquid, and that pencil obviously isn't liters. So, an interesting, good thing to know is 1 milliliter of liquid volume is equal to 1 cubic centimeter of solid volume. So, in this case, our 5 milliliters of liquid that was displaced tell us that that pencil has a solid volume of 5 cubic centimeters. So, you just change the unit at the end. It's a direct conversion, 1 to 1. 1 milliliter equals 1 cubic centimeter. And we'll continue to practice that as the school year moves on. So there's a review of liquid displacement. You need an initial volume and a final volume. In this case of that glue stick, the final volume is 25. So the difference between 15 and 25 is 10. So that glue stick is 10 milliliters of water displaced, so 10 cubic centimeters solid volume. Initial volume, final volume, subtract, and you've got the volume of that object. You also read about the SI units. I just want to touch on that again because that's what we will say in science class. We'll say, what's your SI unit? What is the SI unit? French got to name this. It's Le Système des Internationale, or however you would say it in French. I took Spanish, but in those foreign languages, they sometimes reverse the order of things, or we reverse the order of things, however you want to look at that. SI stands for International System, System International. So, using that international system, we've got some measurements and some units that everyone refers to them by around the world. And you've already looked this up, and I just want to review quickly that length is measured in meters. The abbreviation or symbol for meter is M using a meter stick. Mass measures grams, is measured in grams, abbreviated G using an electronic balance. Time is measured in seconds using a timer, abbreviated S. Temperature, the international standard for temperature is actually Kelvin, but our thermometers in class read in Celsius, and degrees C using a thermometer. Liquid volume is measured in liters, abbreviated L, using a graduated cylinder. All of our graduated cylinders and beakers, though, report liquid volume in milliliters, and we're going to talk about that in a minute. What the heck is a milliliter? That's the purpose of this video, is getting familiar with those metric prefixes. And finally, solid volume is measured in cubic meters, symbol M cubed with a meter stick. So this is all stuff that's going to be on your chapter 1 assessment prefixes. So that's the purpose of today. We should be up to the part of your pre-experiences now where you've got a table to fill in about the metric prefixes, which I'll show you a picture of in a minute. Also, let me point out that at any time you can and should pause the video and go back, or pause it and write down on your papers. I'm just going to keep going. I want this video to be less than 10 minutes, but it should take you longer than 10 minutes to complete this. At any time you need to write things down, go back and look at stuff, pause the video, and then pick it back up when you're ready to move on. Prefixes can be added to base units. That's like our meters or our grams or our seconds. When we have very big and very small measurements, 140,000 meters can be written using a prefix. So we've got 140,000 meters, the same exact thing as if I said 140 kilometers. 140, and our prefix kilo represents 1,000, 140,000 meters. Same number written two different ways using a metric prefix. The prefix kilo means 1,000, and you need to be familiar with at least some of those metric prefixes, which is the purpose of today. Don't start filling in your chart yet. Let me talk about this in the next slide. I've got the chart up there, and can help you fill these in. Let's just look at this and digest what's going on here. So we've got metric prefixes listed in order here. Kilo represents the number 1,000, abbreviated K. Hecto represents the number 100, abbreviated H. Deca, and there's another D, deci. So you've got to know which one's which. Deca is DA. Deca is DA. That's 10 of whatever your base unit is. And of course, the base unit is just one. If you have 2 liters, you would write 2L. If you had 2,000 liters, you could write 2K L, right, for 2 kiloliters. But when you have the base unit, there's no prefix. It's just the number in the base unit. So when you've got less than 10, you would probably use just the base unit. Then we've got deci, which represents zero point 0.1 liters, meters, grams. 0.01 is centi. Again, you could have a centigram, a centiliter. You could have a hecto second. So all these prefixes go with all of your base units. And then we've got milli. You could have a milligram. You could have a millimeter, which you've heard of. You could have a milliliter, which you've heard of. So the prefix tells you that you've got 0.001 grams or 0.001 meters. So that is what those prefixes that we'll commonly use in class are. Remember that they represent multiples of 10. If going up and down, you're multiplying or dividing by 10 at each step. And you do need to know the quantities that go with these. It's easy to memorize if you want to practice real quick. 1,000. If you start a kilo, if you remember them in this order, and we have a way to remember these. If you don't remember learning this, it's King, Henry, died. It's probably not how you spell Henry. Unexpectedly, drinking, chocolate, milk. So if you can remember that King, Henry, died, Deca, unexpectedly, drinking, chocolate, milk, then you know them in numerical order, and then you can remember that it starts with 1,000. I think most of us know kilo is 1,000. 100, deca is 10, base unit is 1, then deci is zero point 0.1, centi's zero point 0.01, and milli's zero point 0.001. So King Henry died, deca, unexpectedly drinking chocolate milk, 1,110, 1, 0.1, 0.01, 0.001. That pattern's pretty easy to remember. So filling in your chart here, what you want to do is, let's try a different color just for fun. Let's use this red. So here you want to do these in order again. Kilo, King Henry died unexpectedly drinking chocolate milk. Kilo, hecto, on down. And then the symbol for kilo is K, and the quantity that it represents is 1,000. So this is that point where you can pause the video and fill that in, because I want to keep this video under 10 minutes. I don't know where I am right now. So fill in the chart there. This is on your paper. And then there's going to be some practice with that. So once this paper is filled in, then restart the video and we'll do the practice on the next page. Pause now. Okay, you've got your table filled in, so you can refer back to it. And now you're looking at these examples on your paper. What type of measurement? What type of measurement? This is saying, what did you measure? Did you measure mass? Did you measure length? Did you measure time? Right? So this is some practice. You've got some problems below this. Here's some practice with this. MG, the last letter in any of these units tells us the base unit. So M stands for milli and G stands for gram. So what did we measure? If we measured milligrams, milligrams measures mass, grams measures mass. So our type of measurement here is mass. KS stands for kiloseconds. What do we measure if we use a unit of seconds? We measure time. So that's the type of measurement here is seconds. And finally, decimeter. It's not deca because it's not DA. Decimeter. Meters measure length. Length. Meters measure length. So that's the first type of problem that you'll have, is what type of measurement. The second type of problem asks you about what do these abbreviations or symbols stand for. M is milli, and L is liter. DA is deca, and G is gram. H is hecto, and M is meter. So again, whenever you have two or more letters, the very last letter tells you your base unit, and the letters before that tell you your prefix. Finally, it's asking you what's the abbreviation for these things. Hectogram. So hecto is H, gram is G, millimeter, M is milli, and meter is also M, kilosecond, K, S. And it is something that's easily confused. What's the, when you have just M or MM, what do you have here? Remember, if it's just one letter, that's your base unit, meter. If you have 7 meters, it'd be written like that. If you have 9 grams, it'd be written like that. No prefix in front of it. So if there's just one letter, that's your base unit. And if there's two letters, kilogram, your first one again is a prefix, second one is your base unit. And you're ready to roll. I think that's all we needed. Now, if we want to go back and look at your paper now. This is the paper that you're working on, and you should be down here. You've already had that checked, and now you've filled in that table, and you did our example problems, and now you're ready to practice. So I just wanted to point out again, this first part is asking you what type of measurement, and so here's your choices: length, mass, solid volume, liquid volume, temperature, or time. Fill that in. This next part, my paper's not cooperating. This next part is asking you about the symbol or the abbreviation. So milliliter here would be ml, right? That's a milliliter, ml. So that's what you need to do here on this one, ml. And then have the paper checked here. You need to get initials. If you didn't get the top part, this should be the second set of initials that you get. You should have your teacher initial your paper here again, and then you're ready to do your lab experience. Have fun. Remember, you can rewatch it, go back a little bit and rewatch any of the stuff that you need to have your paper checked, and you're ready to do your lab.